Inheritance is one of the most important features of object-oriented programming. What it provides is the ability for you to define a base class that generically defines the state and methods of an object, and then you can provide classes that derive from that base class that enhance that definition. Let's start by looking at a class called vehicle. So I'll add a new class to my project, which I will call vehicle. This class will represent a vehicle as it applies to the private purchasing industry. In other words, if you wish to purchase a vehicle, you might see a listing in some trade magazines or online looking through specific websites. As we know, there are many different types of vehicles, so what we need to do is define the basic attributes that describe a generic vehicle. All vehicles at some point have a manufacturer. So we will define a string called manufacturer, and this can be an auto property. We probably also want to define a model for the vehicle. And again, we can define this as an auto property. When purchasing a vehicle, you typically have a date of manufacture. Sometimes this is simply a year, say for cars, but let's also provide the entire date-time structure. So if anybody wishes to put all of the manufacturing date information in, it is available. We'll call this MFG date, MFG being a widely recognized abbreviation for manufacturer. And we'll leave it as an auto property for now. We may decide later on that a traditional property is more appropriate if we need to do some data validation. Let's also add an int for the number of passengers. We can call that passengers, and again, one more time we'll make that an auto property. Let's assume that this is sufficient for our basic vehicle definition. We probably also will want to define a constructor, but instead of typing it out, why don't we just use the quick action tool to generate the constructor, and I'll swap it position-wise with the property definitions. So far everything here looks good. It looks like it's doing everything we need. And we can also provide a default constructor. And for this one, we can either assign predefined values here, or we can put them in with the property definitions, as long as you're using C#6 or above. So let's just assume date time minimum value for a default date manufacturer. We can set that to double equal, or my preference, string.empty. I think it's easier to read this, especially on printouts. And I'll copy that string.empty assignment to model, and the number of passengers will be defaulted to 0. Now, I could reassign all of those values again here in the constructor, but it wouldn't solve or serve any purpose. Now, let's think about how we want to use this class. If I needed to create a car object and use the vehicle as the basis for that car object, I could definitely see some parallels. The manufacturer sometimes is known as make in the car industry. We have a model, We have the year we can store inside the manufacturing date, and we have the number of passengers. But clearly there's far more information about a car than these four fields. So let's go ahead and define a car class that will make use of this vehicle class. Remember, the whole point of creating a derivative class, or one that inherits from this vehicle base class, is to share the functionality between the two classes, yet expand upon it in the derivative. Notice here in vehicle we didn't identify an ID number of any type. Like a car would have a vehicle identification number. It's usually abbreviated VIN, VIN. But that is not the same for all types of vehicles. So it wouldn't make sense to define it at this base class level. That's why we create the derivative class to support additional attributes, fields, properties, etc. So let's call this class car. Now, to derive one class from another, we supply a colon after the class name, and then we type in the base class name. In this case, it's called vehicle. Now, automatically, car will contain all of the public members of vehicle. It would also contain all of the protected members as well. But right now, we don't have to worry about protected. We are going to look at that concept at a different time. But all the public members of this class, manufacturer date, manufacturer, model, and passengers, all of these properties are available directly through the car class. As a matter of fact, if I go to program and I create a vehicle object, we'll call it V1, we'll set it equal to new vehicle, and we'll give it some values. Let's say 2005, 02, 03. The manufacturer, we'll say Acme. Model, we don't really have a model name. We'll just put 3 X's there. Oh, now we need passengers. That's 1. So all of these values are passed to the constructor of vehicle and placed in the appropriate attributes. Well, one thing you may notice is if we create a car, we're not going to have a parameterized constructor yet because we haven't defined one. Anytime you create a new class, you get the default constructor automatically. So if we then specify car1 dot, you will see it has the manufacturer, manufacturer date, model, and passengers. Even though if we go to the car class definition itself, we don't see those properties anywhere here in the class. That's because they are defined as part of vehicle, and car is a type of vehicle. So we're extending that base class's interface. Interface being the things you can communicate with, not interface as in the C# keyword. Let's go back to car and define some of the attributes specific to a car. I already mentioned there would be something called a vehicle identification number, otherwise called VIN. Now, we're going to create this using a traditional property. So I'm going to start by adding a private string variable that will represent that VIN. And because a VIN can contain letters and numbers, I have to make it a string. Then I can right-click, quick actions, and encapsulate the field. And now I have my fully formed property without having to type the whole thing in. I'm not so concerned about the get accessor, but the mutator is going to need a little bit of work. Vehicle identification numbers for a car can contain 17 digits, either letters or numbers, and there are specific formats that must be followed for the number to be legitimate. And we could take the time to code all of those rules in here. However, I'm going to take a very small subset just to demonstrate the use of the property here. So the first thing we need to do is check to make sure the input value is not null or empty. As long as it's not null or empty, then we can check to see if the incoming value is legitimately a 17-character VIN number. So then we'll say if value, let's trim it first, make sure we get rid of all the spaces on the left and right of the string, dot length equals 17. Then we can assign the value to VIN as such. Else, we'll probably want to throw an exception. Just call the argument exception. Message, VIN must be a 17-character value. And the parameter is VIN. Now notice here we have several if statements. One is nested in here, and therefore we should probably also have an else and throw the new exception as well in the case that the length isn't 17. But you could also just add this condition to the first if statement, and we will accomplish the same thing. And this is perfectly legitimate because we are making sure we test for null or empty first prior to manipulating the value string by trimming it and getting its length. So we're saying if it is not null or empty and its length is 17, then we assign the value as such. This type of optimization is sometimes really useful to eliminating a lot of the repeated exception throwing, like I just demonstrated, or other types of logic that you might encounter with complex branching conditions. So now our car will have a VIN plus a manufacture date, the manufacturer, a model, and the passengers. What else would be good to define on a car type of vehicle? A property that most people are concerned with these days would be the miles per gallon. Most of the time this is going to be reported as a whole number, so we'll just leave it as such and make it an int, not a double. And we'll call this MPG for miles per gallon, get and set. Now we could split this into highway and surface streets mile per gallon, but I think this is sufficient to give us a distinctive vehicle compared to the base vehicle class. So car will have these two extra properties, MPG and VIN, available to it. Now we'll create the constructor for this class. Notice I highlighted MPG and VIN to do it, and I'm going to put the constructor below the property definition. I'm not a big fan with how it changed the case for these two acronyms, so I'm going to adjust them appropriately to the way I feel they look better. And now we can create a car with these two values. And if we go back to this program class where we can create a car, you'll notice now we have access to that constructor. There is one small problem, however. Besides the fact that we have to define the VIN using exactly 17 characters, we have no way of assigning the other 4 values that are defined in vehicle through this constructor. Well, that can be a problem. We could, of course, use initializer syntax as such, and then define each of the additional parameters here. And then for the manufacturer date, I'm going to copy this so I don't have to type it all again. Looks like I have an extra parenthesis. Let me get rid of that. And then finally we have passengers. And we can make that a 4. So this is perfectly legitimate. However, most people would not find this acceptable because you're assigning some of the values through the constructor and the others through property assignments. What I recommend is going to vehicle and grabbing the parameter list for its constructor and then appending it to the car constructor. Now, the order of the parameters is entirely up to you. It can follow the base class parameters comes first order, and then the derived class parameters second. Or now that we have a vehicle identification number, you may feel that should go up front, and then everything else should follow. And it doesn't really matter as far as functionality is concerned. Where it might matter is if you create many derivatives of the vehicle class and each has a different ordering of its parameters, especially the ones that are in common between them, then things can get confusing. I'm okay with this layout here where the vehicle identification number comes first, then the other information as such. So we could then assign each of the base properties like this. Nothing wrong with that. However, there is a simpler approach that is supplied by the C# language, and that is to define the specific constructor, or the base class constructor that you intend to call from the derived constructor. This is implied, this syntax right here where it says colon base with the parens. That is saying when a car is constructed using its constructor, then before you do anything within the body, call the default base class constructor. That will trigger this constructor call, and then we'll go back to car and then set MPG and VIN. Well, we still haven't solved our issue yet with assigning the base class values, but we can supply parameters to this base function call which correspond to the base class's parameterized constructor as such, where we have the manufacturing date, manufacturer, model, and passengers. In fact, I can copy that list, paste it into the parentheses, and just get rid of the data types. This way I'm guaranteed the correct order. So now this car constructor will call vehicles constructor that accepts these 4 values first, which will assign to the properties or the corresponding properties within its constructor. Then MPG and VIN will be assigned. Go back to program CS, and now our constructor call is invalid because we don't have a 2-parameter constructor inside of car. What we do have is one that'll accept the VIN, followed by the number of passengers at the very end, and in the middle I can just copy this parameter list from, or the argument list from the vehicle constructor call, and just use that in its place. Now I can get rid of the initializer syntax and just close this with a semicolon. Now, when I run this code, vehicle V1, if I expand it, you'll see it's Acme, and then the date XXX and 1. And if I step over the car's creation, you'll see that all of its properties are set as well. Let's go back to this part where we call the base class constructor. This is mandatory. In other words, anytime you create a derivative class that contains a constructor, that constructor must call a base class constructor. There is no choice. Even in the classes we've created without explicit derivations, such as this vehicle, which, by the way, is implicitly doing this, where it's inheriting from object, even this class is calling the base class constructor behind the scenes. Anytime you don't provide the call to the base class constructor, it will automatically perform this particular function call, the one that calls the base class default constructor. So even though we have our user-defined type that does not explicitly inherit from object, it's being done implicitly, it still must call its base class constructors. We're just doing it behind the scenes. At least the compiler is doing it for us. But when we define car, we have to call one of vehicle's base class constructors, and if the default constructor is not supplied, then we must call a parameterized one. Vehicle does have a default constructor and a parameterized one, so we can call either one, but at least one of them must be called. And again, if I left off this call completely, if I hit delete, it is going to call the default base class constructor. If I were to go back, I'm going to actually put a comment here so I don't lose the code. But if I go back to vehicle here and remove the default constructor, which I had to add manually, since once you define a parameterized constructor, you lose the automatic default one. So I had to do it manually. But once I remove it again and go back to car, now this is going to flag an error because there is no base class constructor call here. It cannot implicitly call the default one anymore because it no longer exists. And because the only one we have is a parameterized one, it can't determine what those arguments are supposed to be. You have to tell it explicitly. I will once again recommission this constructor, therefore making this call legal again, but we really do intend to call it using the base class constructor with these 4 parameters. What about another type of vehicle? Let's create another one called boat. So we'll add a new class, and we'll call it boat. And once again, we are going to specify that it derives from vehicle. Boat will also have an identification number, but unlike a car, the identification number for a boat is typically referred to as a hull identification number. And I'm going to copy this code over here so I don't have to retype the whole thing. I can get rid of MPG. The hull number on a boat is a little smaller than a car's vehicle identification number. Instead of 17, we are going to require 12 characters. But otherwise, it is going to be pretty much the same. So we'll go ahead and add a value to indicate the number of motors that a boat has. Most of the time, a car will have a single engine, but on a boat, it is entirely possible to have 1, 2, 3, even 4, depending on the type of boat it is. So this will indicate the number of motors. I also want to create a constructor for this, so I'm going to move the properties so they're together. So when I highlight and right click and say quick actions, it'll generate the constructor with the hull identification number and the number of motors. Once again, I don't like how it handled the case of the letters. So we are going to have the same problem we did with car, in that our constructor so far is only accepting the hull identification number and the number of motors, but we need the additional values that correspond to the base class values. Remember, the boat is also a derivative of vehicle. We can assign HIN and motors here, but we're going to do the identical base class constructor call that we did in car, because we are calling the exact same base class constructor with the same values. Now I can return to the program class and create a boat. I'll just call it B1 to save some space. It's new, boat. And I can pretty much do the exact same thing I did with car, except now I'm only allowed to have 12 digits, so I'm going to get rid of 5 of these. And I can change the date as I see fit. And we could make this, call it gadgets. Model number or model is YYYY. Okay, and remember that next value is going to correspond to the number of passengers. Let's give this a number of passengers. We can put 8 people on this boat. And this is the number of motors. Notice here I only have 1 passenger. And it gets very bad gas mileage. So let's change that to maybe 30, make it a little more reasonable. Now when we run the code, we can investigate B1 and see that it has a hull identification number and all the appropriate properties are set. What happens if I tried to add one more digit to the boat, via or hull identification number? Then when it's encountered, it tries to assign into the HIN value the wrong number of characters. Oh, notice I have to fix this. It still says 17. It doesn't affect the functionality of the code, it's a bad error message. Sometimes that could be worse than actual coding problem, because you're telling the user or the client a specific error message which is inaccurate, so when they try to fix the problem, they're fixing it to your specifications, which are not correct. So it's a good idea to make sure you, when you do cut and paste or copy and paste, that you appropriately fix all of the values that need to be changed for the destination of that pasting. Let's go back to the program class, and here we can now create a list of vehicles and we can add those 3 vehicles to this list. We can add V1, Car 1, and B1 for Boat 1. The reason we're allowed to do that is because vehicle is the base class for car and boat. And just like if the vehicle base class was an interface like iVehicle, we can store any objects that implement that interface in an iVehicle variable. Well, in this case, we don't have a base interface, we have a base class. So we can put a car within a vehicle object. So we could also do this. Vehicle V2 is equal to car 1. Now, the car is being stored in a variable of type vehicle. If we attempted to print one of these vehicles out, as a matter of fact, let's go ahead and look at adding some printing methods to these classes. But instead of using the traditional mechanism of having a print method, we are going to do something called overriding. And overriding means we can change the definition of a method that was supplied in a base class. Every class, as you may be aware of now, has a method called toString. And that is strictly due to the fact that all classes at some point derive from object, which has a toString method. So if I were to try to print, before I do that, if I try to print v1 by saying console write line v1, and it doesn't matter if I say console write line v1 or console write line v1.toString, both of these in fact will call toString on v1. When I run this, you're going to get a very useless output. And let me actually fix, I forgot to put this back. We're getting an exception from the boat class constructor because I forgot to fix the hull identification number again. But when it prints the vehicle, you see it just says inheritance_demo.vehicle. It's basically the namespace dot class name. Not particularly useful. And the reason this is done is because object would have absolutely no idea what is important for printing on a type to be defined well into the future. Remember, the object data type was created in Microsoft sometime before 2002. So they couldn't possibly predict every possible class that would derive from it from that point onward. So the best it can do is come up with a default functionality for toString. In the case of object, it says the object's fully qualified type name. So we can fix that by going to the vehicle class, typing in override, and then toString. When you select that from the list, it'll fill in this method definition for you. Now, when I run the code, you'll see the exact same thing happens. As you can see, the toString override is simply calling the toString method of the base class, where this base keyword is similar to the this keyword, but instead of referring to this instance of a class, it refers to the base class of this particular class. So if I were to hit F12 or right click and go to definition on this, it will take me to objects toString method definition. So that's really why we don't see any difference in the output. So how do we get a meaningful output? Well, in that case, what we need to do is employ some string formatting. We can use string interpolation for this, and we'll supply maybe the manufacturer date first. And then we can put in the manufacturer. And we're going to limit this one to a certain number of characters left justified. We're going to do the same thing for model. And then finally, passengers. And because we can have a various number of them, we'll assume that most vehicles will contain less than 10,000 people. When we run this now, you'll see much more useful information because the toString method is called and then it is formatted using this interpolation string. What about printing a car? Well, what happens if we put in, instead of v1, we call console write line car1? As you can see here, the output is virtually identical except for one of the values is different. Why is that? Well, let's take a look at what's actually going on behind the scenes. When we try to call console write line passing at car1, the first thing console write line does is check to see if it recognizes what type of object this is. Since this is not one of the predefined .NET data types, it is automatically going to default to calling its toString method. The problem is if you go to the car class, there is no toString method defined here. So what ends up happening is it starts from here and starts walking back until it finds in its ancestor chain a toString method, which it does find inside vehicle. So that's exactly what gets printed. Now, that's not really how it works. In reality, there's something that the CLR manages called a vtable, or virtual method table, which keeps track of the offsets in memory of each of the virtual methods of a class. Now, you may not recognize this, but this toString method is virtual. So let's go take a look at the toString method of object again. I just typed it back in just so I have access to it, and you can see that this method is marked as virtual. A virtual method is a method that is permitted to be overridden in a derived class. And anytime you mark a method as virtual, that method is added to the vtable of that class and any of its derivatives. So when we called toString on a car object, it has the toString member in its vtable, and it exists at the same offset as the one defined in vehicle and the one defined in object. So all that has to happen then is when you call toString on an object, it is going to call the toString method that is pointed to by the vtable. In this case, since we don't override it again in car yet, it will still point to the same memory location where the method exists for vehicle. So we don't have to get too much into detail about how vtables works at this juncture as long as you understand the consequences, such that anytime you call a virtual method on an object, even if you're storing it in a variable of its base type, it will call the appropriate overloaded method. So going back to car, if I want to see data specific to the car, I would once again have to override toString and then supply all of the necessary string formatting here. So I could copy everything that's in vehicle, do a copy and then paste inside car, but I propose that's kind of a waste of keystrokes, or even in this case just waste of space. The reason is we can make use of what is in the base class's toString member from this particular override of toString. First, let's define the VIN as part of the output. So we'll supply VIN here, and we'll make that 17 left justified characters. And then we know we're going to have MPG. So we'll supply MPG as this substitution, and we'll make that 3 right justified characters. And then in the middle, well, let's run this right now real quick so you can see exactly what's happening. So you can see there's the VIN and there's the MPG, but none of the base class entities are printed. I can fix that by supplying within this set of curly braces base.toString. Now it is going to inject right here whatever vehicle outputs in its toString member. And now you can see we have the VIN followed by all of the vehicle base class fields or properties, and then we have the MPG value. We can do the exact same type of functionality inside boat. I'm just going to replace the VIN with HIN. Make sure this is left justified 12 characters. It's not MPG anymore. It's going to be motors. And we really only need probably one right justified character for that. So if I print out a boat, again, I don't need to explicitly say toString after B1 because it'll automatically call that, at least console writeline will. And now you'll see the boat information printed out. We could also do all of that within a for loop. So for each vehicle V in vehicles, console writeline V. And just to show that it's in fact doing it separately, I'll put another console writeline here to separate the output. And you can definitely see now, by treating everything as a vehicle, we're still able to call each of these specific objects toString members without any confusion as to which one is going to be called. It's whatever the most derived version of that method is going to be. But what happens if we are in a situation like this where we have a car stored in an object of type vehicle? Let's go ahead and move this particular code down to the bottom so we're not intruding on our other tests. And if I want to convert this back to a car, let's call it car2, I cannot simply do an implicit assignment like I did when going from car to vehicle. So if I want to store an object in a variable of its base class type, that's implicitly done. All I have to do is this assignment. However, if I need to go back where I take a parent object variable and try to cast it directly into a derived type, it won't let me do that implicitly. I have to explicitly cast it. So I could do it this way, where it explicitly casts it back to a car. However, with polymorphism, which is what we're doing, we're playing with objects taking on many different forms. With polymorphism, we have better functionality than that. We can say if v2 is a car, test to make sure it is a car first, then we can say car c2 is equal to v2 as car. So the is operator checks to make sure that what is contained within v2 is in fact a car object. If it is, then we are allowing it to do this conversion. And notice here, instead of using a cast with the parentheses in front of v2, we're simply saying v2 as car. For polymorphically related types, let's just say that they're related because one is a parent to the other. This is a much faster operation than using the cast operator because it doesn't actually do any conversion. It's just saying treat it as a car, not convert it to a car. So that's why it does the treat it as a car rather than convert it to a car, which a cast would be. Because we don't actually have a definition for an explicit cast operator, it's not going to be that much more efficient. It's not going to run that much quicker, but it is the appropriate way to handle converting between objects hierarchically like this. Let's play with that as operator a little more. First, let's do a quick test to see if car1 is a car. I think we can agree that it is, because car1 is explicitly declared as a car type. But we can still do the test. We'll say console write line car1 is a car. Else it is not a car. What happens if we do the exact same test, but this time, instead of car, we test it against vehicle? Well, then we're going to see if car1 is in fact a vehicle. What happens if we do the exact same test again, but this time test it against object? Probably want to put this as an for correct grammar. And then finally, to prove that we're not just being silly, we're going to test to see if it is a boat. Now notice it's already underlining it, and it's telling us it can never be of type boat, because the compiler knows that there is no connection between the two types. But let's go ahead and run this anyway. You can definitely see car1 is a car, car1 is a vehicle, car1 is an object, but car1 is not a boat. So this is that whole concept of an is a relationship. Car is a vehicle, car is an object. And likewise, vehicle is an object. Boat is also a vehicle and it's also an object, but it's a sibling to car. So they are not related in a parent-child relationship in the derivation hierarchy. So that is why it is not a boat. Now, as far as multiple inheritance is concerned, .NET, or at least C# in the .NET framework, does not allow for multiple inheritance. In other words, defining a class like car and having it derive from multiple classes, whatever the other class happens to be. This is not legal. You can do multiple interfaces this way, so you can derive from the vehicle class and then supply a list of interfaces afterwards. There's nothing wrong with that. But you cannot derive from multiple classes simultaneously. But what you can do is continue deriving new classes from the existing ones. So let's assume that we wish to create a new class that has many of the same features as car, but we need to add something more specific that car necessarily should not have. So in that case, we can define a new class, and I'll call it race car. And we will start doing the exact same thing, but this time we will derive from car. Notice it's complaining because we have no base class constructor that accepts no parameters, because when you define a new class, it gives you a default constructor which automatically will attempt to call its base class constructor with no parameters. We have no such constructor. We only have the one that's parameterized. So that is what racecar is complaining about right now. Okay, to fix that, we would have to create a constructor that calls the base class constructor appropriately. I can copy car's constructor, at least temporarily, and then have it assign the values appropriately. Oh, better make this race car, not car. As such, see now it calls the base class constructor with all of these parameters. So all we have to do is when we add our new attributes to this race car class, we just have to modify the constructor appropriately. Let's assume the only thing we need to add to this class is a bool property called roll cage. So it indicates whether or not this race car has a roll cage. Clearly there's far more we could add to this besides roll cage, but it's good enough for our definition to demonstrate how we can utilize yet another base class, but this time the base class is car, which was a derived class of vehicle. We need to add roll cage as a parameter. So we'll throw that in here. And then we're going to want to override toString again. If I go back to the car class, notice here it's just doing the formatting of VIN, base, toString, and miles per gallon. We're going to do something very similar, except we don't have VIN. We'll just say everything in the base class, toString, followed by roll cage. And it can be true or false, so we need 5 characters for that. And we can also make that left justified. So we go back to program. Let's go ahead and construct a new race car. Call it RC1 equals new race car. Then we need a lot of arguments, which I'm going to steal from the cars constructor call. And it does have a roll cage, so that'll be the last parameter. And we can change these so that at least they look different. And Acme is still the manufacturer. This time the model will be ZZZ. It has 1 passenger and it gets 8 miles to the gallon. Seems appropriate for a race car. Then we can write out to the console window the toString for that race car. We can also add it to our vehicles collection. Remember, we have this vehicles collection. Because it is a vehicle, we can add RC1 to that list, and we can print it if we decide to do so again. Oh. And again, we've run into a problem. We have the VIN must be a 17 character value. So let's go take a look at what we did wrong. Did I accidentally delete some characters? 1, 2, 3, 4, 5, 6. I sure did. And this is why we have those data checks inside the properties. It not only keeps the users honest, it also keeps the developers honest. So now you can see we have the same output a car would have, but we add true at the end here, which indicates it has a roll cage. So this wraps up our quick look at inheritance in C#. There will be other examples that will build upon what you've learned here, but this should give you enough of a foundation so you can understand the relationship between a base class and a child class, as well as how you can convert between one and the other.